Hello friends, last class I discussed about the how to minimize the KMA by using the essential prime implicant, this thing. Okay, so if we have the complex function or if you have the more number of min terms, that term you will not able to understand how can you group in KMAP. Okay, for getting the minimization, you have to do the grouping for KMAP. Okay, so that is little bit difficult. For getting how many groups we have to consider for writing the minimum expression. Okay, so that's why I told that if you draw the KMF, after drawing the KMF we have to mark min terms, okay, in KMF, and after that you have to consider group based on the prime implicant and the essential prime implicant. You have to find out the essential prime implicant, and you have to write the essential prime implicants in the final expression. Okay, now so by seeing the KMAP, sometimes it is also difficult to find essential prime implicant, okay, and prime implicant. How many prime implicants should be there? Which prime implicant I have to remove and which prime implicant I have to choose? So by seeing the KMAP, it is also difficult. Or if you have the more than four number of variables, okay, that time it is you cannot use the KMAP. If you want to use the KMAP, five variable KMAP, it is very difficult. Okay, so two things. If you draw the KMF and by seeing the KMF you want to calculate the essential prime implicant, so it is very difficult sometimes. Okay, and for five variables it is you cannot able to draw the KMF also for five variables. So if you have more than four number of variables, and if you are not able to understand how to find the essential prime implicant and prime implicant, so for that Quine-Mccluskey method is required. So Quine-Mccluskey method, that is one kind of the method to minimize the to calculate the essential prime implicant and prime implicant for writing the minimized expression. Okay, by this is a one kind of the tabular method. By using this method, we can easily find out essential prime implicant and prime implicant. If you get your essential prime implicant, you can easily write the expression. What is the final expression for a particular question? So now I will give you the one example of the Quine-Mccluskey method. How can you solve the expression to get minimum expression for a Quine-Mccluskey method, that I will discuss now. Okay, so I am writing the expression here. Okay, 0, 1, 3, 7, 8, 9, 11, 15. These are my min terms. Okay, so you have to minimize that. So you can see in this question how many min terms are there? 1, 2, 3, 4, 5, 6, 7, 8. That means 7 min terms means if you want to write the expression from by using this min term, you will get the 7 product. Okay, this is not minimized expression. So by using the K-map and by calculating the essential prime implicant from K-map, you can find out the minimized expression. But sometimes it will be you will face some difficulty to get those minimized expression. Okay, so for that Quine-Mccluskey method is required, right? So first process is that, so here I am writing all the min terms. Okay, all the min terms, whatever min terms are available. M naught. Okay, M naught means 0 0 1 0. Okay, now M1. M1 is 0, sorry, M naught is 0 0 0. M1 is 0 0 1. M3 0 0 1 1. So I am writing the binary number of all the min terms. Okay, M7 is 0 1 1 1. Four variables, that's why I am writing all the min terms in four variables. M8. Okay, okay, I will do this one more example which has the don't care. This I will not do. Okay, so I am doing the one more example which has the don't care. Okay, right? So M7, 9, 12, 13, 14, 15. Okay, along with this, I have don't care 4 and 11. Okay, 7, 9, 7, 9, 12, 13, 14, 15, 4 and 11. Okay, these are my dream means don't care. I have midterms in this cells and don't care in this cell. So first I am writing all the mean terms. Okay. 7 means 0, 1, 1, 1. 9 means 1, 0, 0, 1. 12 means 1, 1, 0, 0. 13 means 1, 1, 0, 1. Okay. 14 means triple 1, 0. Right. 15 means 4, 1. 4 again, I don't care, I am writing letter. Okay. 4 means 1, 0, 0, 0. M11. 11 means 1, 0, 1, 1. Okay, this is the first procedure. Whatever midterms are there, including don't care, I have written the binary number of all the midterms. Okay, next, this is the first step. Okay, second step. In second step, what you have to do? Okay, I have to group all the midterms based on the number of ones. Okay, I have to group all the midterms based on the number of ones present in each midterm. Okay, so here you can see, first I have to check, do you have any min terms which has no one? Okay, so do you have any min terms which has no one? Okay, suppose m0 has no ones. You can see in your min terms you don't have any m0. Okay, so first next is the, I have to consider how many single number of ones are there in midterm. Okay, how many midterms are there which has only single one? That I am first checking. Okay, I have to separate out those midterms. Right? Single number of ones are also not there. Oh, see, it is single number of ones. M4. Okay, this is my group 1. Okay. Next is the group 2. As you can see, no more midterms are there which has single one. Okay. Next is the group 2. In group 2, I will find the midterms which has two number of ones. Okay, in group 2, I will write those midterms which has two number of ones. Okay, so here you can see M9, 1, 0, 0, 1. After M9, we have M12 also, 1, 1, 0, 0. So this is the another group. Okay, so I am grouping all the midterms based on the number of ones present in each midterm. Okay, no more two ones are there, right? Next is the group 3. In group 3, I will find those midterms which has three number of ones. Okay, first is the M7. Okay, M7. M7 is 0, 1, 1, 1. Next is the M13. M13 is 1, 1, 0, 1. Next M14, triple 1, 0. Okay, M11, 1, 0, 1. Last group is no more midterms other which has three number of ones, right? Next is the M15. You can see it has four number of ones. Okay, so I have total four groups based on the number of ones. Okay, first procedure, and this is the second procedure. Okay, now I have to consider the third procedure. Okay, in the third step, what I have to do, I have to match each group with the consecutive group. I have to find the matching term between two consecutive groups. Okay, so here I have to check so whether my M4 is matched with M9 or M12 or not. Again I have to check these group 2 midterms are matched with group 3 midterms or not. After that I will check group 3 midterms are matched with group 4 midterms or not. How will check whether it is matching or not matched? So when it will be matched? If I compare, suppose this M4 with the M9, I have to check all the bits. If there is only single bit change, that means this midterm is matched with the other midterms. Consecutive group approach. I will not compare this G1 with the G3. I will compare with G1 with G2, and G2 with G3, then G2 is with G4. Okay, when it will be matched? If there is only single bit is changed. Okay, then you can tell both the midterms are matched. So after, if suppose the midterm is matched to the next midterm, then I have to put a tick mark here in the right hand side. Okay, so here you can see now I am start to group G1. So it is G1 dash I am writing. Okay, So this is matching with this one, and the matching term on right here, that is considered as a G1 dash. Okay. Now you can see here M4 is matching with M9 or not. This is same, this is same, this is same. Only this bit is changed. Okay, right? Sorry. M4 is this one. Okay, I forgot this is 848. So M4 is 0100. Okay. So I forgot to write this one. M4 is 0100. Now you can see this is not matched. Okay, the 01 is changed, 10 is changed, 00 is same, or 01 is also changed. So M4 is not matched with the M9. So I cannot put tick sign here. Okay. Now so next time come to the I have to go match check M4 with the M12. Okay. I have to check M4 with the M12 whether any single bit changes there or not. Right. So here you can see this is same, this is same. Also these three are same. One here also 100, here also 10. Only this MSB bit is changed. Okay. That means M4 is matched with the M12. Okay. So here I am writing M4, M12. What is the so the if so you can see this bit is changed, right? This bit is changed. So here it is 0, here it is 1. I have to put a dash mark. And all three bits are same. Okay, in this way I have to write. Now come to the group 1 is already compared with group 2. Okay. Now come to the group 2 and group 3. So for group 2 and group 3 I am comparing first M9 with all the midterms, then I will compare M12 with all the midterms. Okay, so I start with the M9 and M7. So here you can see this is the different, this is also different, this is also different, this is changed. Okay, so that you cannot consider, only single bit is same but all our bits are different. Now I come to the M9 with M13. This is same, this is different, this is same, this is same also. So M9 is matched with M13. I am writing here M9 and M13. What will be this? This will be 1. This is remain same. 1. This is different. Dash. This is same. This is same. Okay. So, so now M9 should be compared with M14. Now here you can see this is same. This is different. This is different. This is also different. So M9 is not matched with the M14. Now come to the M9 and M11. Okay. So M9 and M11. Now you can see 1 same, 0 same. This is different and this one is same. Okay. So now M9 is compared with M13. This will be 1. This is also same. This is different. 1 and how I am rewriting? So M9 and M11 I am checking. So this bit is same. Same writing here. This 0 also same. Same writing here. Here it is 0, here it is 1. This bit, third bit is changed. That's why I am putting the dash mark. And again fourth bit is remain same. Okay. So M9 I have compared with this all the mentors. Now come to the M12. Okay. So this M9, M13 also compared. M9 and M11 also compared. Okay. So I put it tick mark. Now I have to compare M12 with all the midterms, right? So M12, M7. You can see different. It is not matched. Okay. So M12 and M14 I am checking. M12, M14 I am checking. Okay. M9, M7 is different, same, different. So M9, M12, 13. This is same, this is same, this is huh. So you can write M9, M13 again. Sorry. M12. M12 and M13 I have to check. This is same, this is same, this is same. M12, M13. Okay. So here you can see 1 is same, 1. 1 is same, 1. Now 0 is same, 0. This you can here it is 0, here it is 1. So dash mark. M12 is compared with M13. Okay. Now come to the M12 and M14. Okay, M12 and M14. Here it is same 1. Here it is also same. Here it is different. Here it is same. So it is also compare M12, M13. Okay. So M14. One same. Here you can see this is also same. It is different. It is same. Okay. Right. So now I come to the M12, M11. So one was same, one zero different. This is also different. This is also different. It's not possible. Okay. Right. Now come to the this group. Now here you can see I have to compare these all the midterms with M15. Now you can see if we coming to M7 and M15, this bit is different and these all the bits are same. So M7 is compared with M15. Okay, M7, M15. Okay, right? So how can write M7? So M7 only MSB bit is different, all other bits are same. Okay, got it? Right? Okay. Now here you can see now you can see all the midterms are matched. You can see I have mentioned a tick mark in all the midterms. Okay, so that is not required. This table is not required for future purpose. Okay, if you see any midterm is any along with any midterm, if tick mark is not there, then you have to consider those midterm for future purpose, right? So here you can see in this midterm, along with all the midterms you have mentioned the ticking. That means all the midterms I have included here, or any one midterms is matched with the other midterms. All the midterms I have written here. Okay, so I can remove this one because these tables are not required for future purpose. So I am removing these tables. Okay, right? Now come to the fourth. Again same procedure you have to do. I have to compare this group with the this group. Okay, I have to compare this group with the this group. Okay, so first I am checking G1 double dash. Okay, this group with this all the four. So it is little bit difficult. How can you compare, right? So how can you check? So here it is dash mark. I when so that means if there is only single bit change, that time I will consider. Okay, I will consider as a matched pair, right? So here you can see how will check. So here you can see the MSB bit you have the dash sign. Okay, when it will be matched, all the bits should be same. Only other single bit should be not same. Okay, so that means if want to try to match this term with this fourth term, it should in this mean terms, okay, you should have the dash sign in the MSB. In those products you should have the dash sign in the MSB, as in this product you have the dash sign in the MSB. Okay, so I am checking if I try to compare this group with this all the four groups. Now you can see there is no dash sign in the MSB. So this product is not matched with this one. That's why I cannot put a tick mark. I hope you have clear. So how can you match? That means all the bits should be matched. Only one bit should be changed. Okay. So if you see if this bit is different, then you can. It's not required to check other bits, right? So here you can see. So if MSB is dash, so here in anyone MSB dash sign is there, in MSB no. That means if the MSB is different, other bit also will be different. Okay, by seeing this one, that's why I can easily tell that this is not matched with this one. So I cannot put the tick button. Okay. Now come to the these four should be compared with this one. So here first I am checking this one. This one in second same way I have to check. The second bit there, second position dash sign is there. So I am checking here. Second position dash sign is not there. Okay. This is also not matched, right? Now come to the this one. Okay, this one also I can see in the second position there is no match term. Okay, so now okay, so if you see first position, okay, if you see first position, I think I some groups I left. I am writing here in G3. you will have some group. Okay, in G3 dash you will have the M13, M15. Okay, I skip this one. M13, M15. This will be 1 1 dash 1. Okay, then M14, M11. Okay, I skip some group, I think, right? So this will be triple one dash and M11, M15, 1 dash 1 1. Okay, right? So this is the entire thing. Now come to the third step. Okay, this is under G3 dash. So here you can see, if you want to try to match this group with this one, no one is matched. Now come to the here. This group should be compared with this one. So first we come to this one, M30, M9, M30. Okay, you have to check in the second position you have the MSB. In these four terms, you have any second position here. Here you can see in this second product you have the second position dash, which includes dash, right? So that means this is matched with this one. Okay, M9, M13, M11, M15, right? This is matched to this one. How can you write? This one is same here, 1. Dash is also same here, same. Here you can see it is 0 and it is 1. That means again you have to put dash mark. And the MSB also, LSB also same. Right? So this is matched with this one. Right? Now again come to this one. So here this should be compared with this 4. So here you can see third sign in the third bit and dash sign is there. Where in the second group third sign is there in third bit, you can see in here. Right? So M9, M11 is compared with M13, M9, M11, M13 and 15. You can see same. 1, 1. So here it is 0. 0 means dash I have to put. Here it is dash. Dash means dash. 1 means 1. Okay. Now come to this one. This one I have to compare with these 4. Okay. So if I try to compare this one with this 4, here you can see in the LSB you have the dash sign. Why my dash sign is there? Here. Okay. So that means this is compared with this one. Okay. So here it is M12, M13, M14, M15. Okay. So it is 1. Again it is same 1. You can see this is different dash and this is also dash. Okay. Now I am to compare this with this 4. Here you can see in the third position you have the dash, right? The third position you have the dash. So this should be compared with this one. Okay. So here it is M12, M14, M13 and 15. So now you can see first two are 1 1 same. Third is the dash. Fourth is the 0 and 1. Again you have to put dash. Okay. Right. So now you can see here, if you see the previous table, okay, this is the entire table. If you see, so this is only one group, okay, you cannot compare this group with the other groups because in here only one group is present. Okay, I have to stop the procedure here, comparing matching procedure, I have to stop here, right? So now you can see, if you see this table and this table, this is the step 3 and this is the step 4. Okay, first come to this table, right? In the first table I have seen all the groups are matched. Okay, now if you come to this table, now you can see here I did not mention tick mark, here also I did not mention tick mark, right? And here also all I did not mention any tick mark, but you can see in this table these two products are same, these two products are same, because here in both products you have 1 dash dash 1, if 1 dash dash 1. Here also you can see double 1 double dash, double 1 double dash. So you can remove one these two products, okay, because both are same only, right? So in this table I have to understand how many prime implicants are there. So wherever you, if you see, wherever you see the tick sign is not there, these are my mean term. If along with this product, if you see tick sign is absent, that means those products are my prime implicant. Now you can see here tick sign is absent. So now you can see, so if you want to write the expression for this is my prime implicant M4 M12, which is what is the product for prime implicant. Okay, dash means this bit is changed. That's why I put the dash mark. So that means you can see you have to consider these two bits, these three bits. That means this one means it is B. C, it is C, it is D. That means C prime, D prime. Okay. So I have removed this one. Now you can see in the same table you did not mark this term also. Okay. So this is one more prime implicant M7, M15. What is it? This dash I cannot consider. Dash sign is cannot consider. Okay. These three I have to consider. It is B, C, D. Okay. Now I am removing this one also. This one also. Here also. Now come to this group. In this group, in both I did not put any tick mark because you cannot compare this with the other group. Right. So your M9, M13, M11, M15 also your PI. These are my PI. Okay. So here only these two number I have to write. This is A, this is D. M12, M13, M14, M15 I am writing. These two bit I have to consider. These are dash. Dash sign I cannot consider for writing the expression. So this is A, B. Okay. So these all are my prime implicant. Okay. If you know how to compare, how to do the tabular method, it is very easy to calculate the how many prime implicants are there. Okay. Now we have to calculate from the prime implicant how many essential prime implicants are there. Okay, we have the four prime implicants. From the four prime implicants, how many essential prime implicants are there? You have to consider. Okay, so for that you have to again draw one more table. Okay, so in this table in vertically I am writing the all the mean terms. Okay, so M4, M12, M7, M15, M9, M11, M13, M15. This I am writing here. Okay, this is also M12, M13, M14, M15. Okay, and vertically I am writing all the mean. So vertically I have written all the PI. All the PI I have written. Okay, now horizontally I am writing all the mean terms 7, 9, 12, 13, 14, 15. 4 and 11 are not required to write here because these are don't care only. Here I have written all the PIs, but here I did not write all the mean terms. Only I have written mean terms. I did not write the don't care here. Okay, it is not required because it's when you do the grouping and camera, you can see it is not required to consider don't care. If along with don't care, if anyone is present, right? So here also I am not writing don't care 4 and 11. Right. So now you have to see M4 and M12. So I have to put a cross mark under this. Okay, so M4 is I did not write here, so not required. M12 I have. So I am putting cross mark here. Okay, under the M12. Now M7, M15. Okay, M7 here, under the M7 I have put cross mark and M15. Then M9, 11, 13, 14. 9, 11 is not required. 13, 15. 13, 15. Okay, now 12, 12, 13, 14, 15. Okay, right, got it. So now I am matching this mean term with mean term present in PI with this all the mean terms, and I am putting the, if it is matched, then I am putting the cross mark. Okay, M4, M12. M4 I did not write it, only M12. Under the M12 I put cross mark. M7, M15. Under M7 cross and under M15 cross. In this I have done for test two things, right? Now vertically I have to check how many cross signs are there. So you can see, if you vertically, if I see this column, only single cross is there. So I have to put a circle. Now if you see the second column, you can see only single cross is there. Vertically I have to check the cross mark. If you find any single cross vertically, I have to put and circle this cross. Okay. Now here under this no single X. Here also under this you cannot see. Here you can see only this one is single x in this vertically. Here also you cannot see any x. Now, wherever you encircle this cross, so you have to after that draw a straight line. Okay. Now you can see in this straight line which mean terms are crossed, which mean terms are covered, right? M7 is covered and 15 is also covered. Okay. So when you put drawing the line horizontally, I have to mark this cross line. Okay. First, I have checked vertically any single cross is there or not. Okay, if I vertically single cross, I am putting a and circle. I am drawing a and circle. Okay, now in each circle, I have to cut the circle. Those have circle. Okay, I have to cut the cross. Those have circle horizontally. So I am cutting. You can see one more axis cutting here. Okay, so I am marking M7 and M15. These two are cutting in this horizontal line. Now here also you can see these three are cutting. Okay, 9, this is 13, also 15. Okay, so when I am drawing the cross line, I am checking all the midterms are covered or not. Now here also I have to cut this straight line. I have to draw a straight line. Okay, along with this end circle. And you can see here which term is covered, 12, 13 also covered, here also 14. So you can see when I am drawing the horizontal line, okay, which includes this circle, where all the midterms are covered. That means, so we have covered all the midterms when we are doing this tree procedure, okay. That means these three are my essential prime implicant. This is not required. Because if you choose this one, it is already included. The 12 is already included when I mark these midterms in other groups, okay. So this is not required. So first you have to encircle the single cross. Okay, vertically I have to check the single cross and encircle. Then I have to draw a straight line along with this single cross. Okay, and you can see which any more cross is there or not in that straight line. So if any more cross is there, I am marking from here. Okay, that means you can see. So after doing this procedure, you can see all the midterms are covered. That means these three are my essential primary. So if after drawing this thing, if any more midterm is left, that time I have to consider the corresponding PI as a essential PI. Otherwise, it is not required. Okay, these three are my essential primary care. So that means this is not required. These three are. So what is my F? F is BCD plus AD plus AB. So these three are my essential prime implicant. I have to write these three midterms in the function. Okay. So I hope it is clear how can you do the Quine-Mccluskey method. How can you calculate the prime implicant followed by essential prime implicant using Quine-Mccluskey method. So it is clear. If you have any question, I will give you the one more example if you need. Okay. Thank you. Please subscribe my channel.